Hola, welcome to this video 3-1. This is the last video, part 3 of position velocity and acceleration. In this video, we're going to look at a graph, position graph, and then we're also going to consider a contextual problem and answer some questions about position, velocity, and acceleration. Okay, so without further ado, here is the graph, and it says this shows the position of a radio-controlled model car, and they just want us to answer some questions and explain. So number 12, it says, was the car going faster at A or B? Well, A is right here. Sorry about that. And B is right here. So how are we supposed to know if the car is going faster? This just shows position. Well, velocity, right, shows speed, but velocity is with plus or minus with sign values equivalent. So what we can do is we can take the slope. What is the slope here of this tangent line? Okay, and that is our velocity. So there's A, there's the slope there, and B, here is the slope at B. Okay, and you can get a rough idea. So the bigger the slope, right, the faster the vehicle is moving. The vehicle, it's a remote controlled car. Okay, so which of those is steeper? Well, that's going to be point B. So we can say the car is going faster at point B, and we need to explain because the slope of the position, aka velocity, is greater than at A. Okay, when was the car stopped? Well, if your car's stopped, right, your position is not increasing or decreasing, and you can see that that's the case here, right? My position's not increasing or decreasing at all. My slope, my velocity, right, is 0. So there's a couple ways you could explain this. You could explain, right, that your position is not moving, right? It's flat, right? I'm not moving up or down, right? Our y-axis is our position. Okay, so whoa, what's going on? My computer is freaking out right now. I hope it's not dying. Hey, Ella. Okay, so we'll go ahead and say that. So the car is stopped from C to D because the velocity, right, and we know that this is the slope of the position, is 0. Okay, 14 and 15 are kind of the same question, but you need to interpret them. At which point is the car's velocity the greatest? So again, they're asking us about speed. So notice, right, I have A, there's my speed there, B, there's kind of my speed, my slope. We know between C and D the car's not moving, and then after D at E and F, those are pretty steep. However, they're in the negative direction, right? So here's E, right? That's really steep, and then at F, we start to tail off there. Okay, so if I'm just looking for velocity, right, that's got to be positive. It's only A or B, and we already said point B, right, is bigger. So we can say the velocity is the greatest at B because that's when the slope is the greatest. Easy enough. 15, they're asking about speed. Remember, speed is the absolute value of velocity. So it doesn't matter, positive, negative, doesn't matter. Now we can compare E and B. And if you look at E and B, I think you would agree that E, that's a kind of a steeper slope, right? So we can say that. We can say the speed is the greatest at E because that's when the absolute value of the slope is the largest. Okay, so easy enough. All right, now onto the back side. Here we have vertical motion examples, and this is a great classic problem. It says, suppose S of t, which is position, gives the position in feet above the ground for a ball thrown into the air from the top of a cliff, where time is measured in seconds. So you can imagine, here's a cliff, right? Here's a little person, and they throw a ball into the air, and it's coming down. Okay, so they say find the initial velocity of the ball. Okay, so remember S of t, this is position. We want velocity, so I need to find v of t, and that is s prime of t. Okay, so v of t is equal to, and if we do our power rule, we have negative 32t plus 48. Okay, and then I want the initial velocity, so all we do is evaluate at 0. So v of 0, which gives us 48, and then again we want units, right? So velocity, this is feet, and this is seconds. And again, I told you, draw a little axis right here, right? This is our function S of t. This is the position, okay, which is in feet. Okay, and then here is time, t, which that says seconds. Okay. 17, at what time does the ball hit the ground? Right here. So how long until the ball hits the ground? How am I going to know that? Well, you want the height to be 0, right? I'm going to set the function s of t. Okay, I'm going to set that equal to 0. That's when it hits the ground. Its height is 0. Okay, so all I do, I take my function s of t, negative 16t squared plus 48t plus 160, set it equal to 0, and I solve. Okay, so there is a GCF here of negative 16. We'll factor that out to give us t squared minus 3t minus 10 equals 0. And we'll use our AC method here. This is t minus 5, t plus 2, and we solve. T minus 5 equals 0, t plus 2 equals 0, and we get t is equal to 5 seconds, and t is equal to negative 2 seconds. So this is when the ball hits the ground contextually, right? If I throw a ball up into the air, negative seconds does not make sense contextually. So your answer here is at 5 seconds. That's when the ball hits the ground. That's a 5. Okay? All right, and then last but not least, at what time does the ball reach its maximum height? When is it the tallest? And for this, I'm going to refer over to my beautiful drawing here. Okay, so here's my ball falling to the ground, and I hope you would agree that that happens here. That's when it's at its maximum height. Again, I drew this horizontal line because I want you to imagine the slope being 0, right? When a ball reaches its maximum height, its velocity stops for a brief second, right? And then the ball starts to fall again, okay? So what I want to do is I want to know, when is v of t equal to 0? That's what I'm really interested in here, okay? So I'm going to go back over here. I'm going to steal v of t, which is negative 32t plus 48. And I'm going to say, when do u equal 0? Plus, I just want to make sure, okay. Okay, and then we solve. So negative 32t equals negative 48. T is equal to negative 48 over 32, divided by negative 32, which makes it positive, which is 3/2, which is 1.5. And again, this is seconds. Okay, so at 1.5 seconds, the ball reaches its maximum height. All right, so that is it for position, velocity, and acceleration in the examples. Oh, my computer's dying just in time. Okay, so I hope you enjoyed this video. I'll catch you next time. Peace.